Today we're going to learn two different things. We're going to learn how to find the distance between 2 points, and then we're also going to learn how to find the midpoint between 2 points. Okay, so we're going to start with distance. So in these problems, they're going to give you 2 points on a graph, and they're going to say what is the distance between them, or what is the length between the 2 points. And so remember, your points have an x and a y value, so you're going to have an x1 and a y1 value. That would be like your first coordinate. And then you're going to have another coordinate, so they would label that as like your x2 and your y2 value. Okay, and so they're going to say find the distance between these 2 points. Okay, so one way that you probably would have learned to find the distance is the distance formula. So the distance formula is a doozy, okay, but it is a formula that you'll just plug your numbers in, and then it will tell you how far those 2 points are away from each other. So the formula that you would have to memorize to find the distance between 2 points is you got a big square root, and it's going to be over. You start by finding the distance between your x values, so you would take your x values and subtract them. And then you would square that, and then you add that to, you take your y values and find the distance between them. So it'd be y2 minus y1, and then you square that. So if you were using the distance formula, you would just plug in your numbers. So you'd take your x2 and your x1 value and you plug them in there and subtract them. Then you would take your y2 and your y1 value and plug them in there, and then just type that in your calculator and then figure out the distance, okay, which you can do. The other way that you could do it is you could actually use the Pythagorean theorem to find the distance between the 2 points. So we'll be talking about both, but the Pythagorean theorem is a much easier formula to remember. So Pythagorean theorem is a squared plus b squared equals c squared. And so usually this is used for right triangles. So these are your legs, the lengths of your legs, and then that's your hypotenuse. And so this will actually be helpful to find the distance as well. Okay, so there are some steps that you take to find the distance using Pythagorean theorem, and we'll go ahead and write those down. So the first thing that you would do if you were using Pythagorean theorem to find the distance between your 2 points is you would start by graphing the points on a graph. Okay, so graph the points, and then you're going to connect the points and then make a right triangle with them. So I'll talk about that in a bit. So you draw a right triangle, because remember, like I said, the Pythagorean theorem deals with right triangles. And then after that, you will be able to use the Pythagorean theorem to find the distance between the 2 points. Okay? So now that we kind of know what are the 2 ways that you can find the distance, let's actually do some examples. So like for number 1, it says find the distance between the point 1, negative 2 and 3, 4. Okay, well, if we were using the distance formula, I would take my 2 points and I would label them. So I'm just going to copy my 2 points over here. So we're finding how far the points 1, negative 2, and how far that is away from 3, 4. Okay, let me adjust this so I guess you could see it maybe a bit better. It's kind of blurry, so I'm sorry. All right, so I'm going to label them. So this is my first coordinate, so I'm going to label that as my x1 and my y1. This one, that's my second coordinate, so I'm going to label that as my x2 and my y2. And then I'm going to plug it in the distance formula. So to find the distance between the 2 points, it's going to be a big square root. And then you start by taking your x values and subtracting them. So when you do this, what you're actually doing is figuring out how far this x value is from that one. So you could actually kind of reason through that. But if you wanted to just plug it in, so it's the x2, so 3 minus whatever the other one is. So make sure that you just take one, put a minus, and then put the other one. And then you have to square that. I will tell you the one part that most people forget with this is they forget to square it. So if you're using the distance formula, don't forget to take this and then square it. and then you put plus, and then you plug in your y values. So you're going to take y2 minus y1. So my y2 is 4, and then it's minus whatever the other one is, so it'd be minus a negative 2. All right, and then you square that. Okay, so from there, you could simplify it a bit, or you could just take your calculator, or if you are using the Desmos app, you'll pull up your Desmos app and you'll type it in. So I'm going to show you how to type this one in. So you start with the square root, okay, and notice it'll be flashing underneath it, and then you type in your equation. So it'd be 3 minus 1, and then that's got to be squared, so I'm going to hit the little a squared button, plus, and then it would be 4, and minus a negative is technically a positive, so I'm going to just change that to a 4 plus 2 underneath, and then that would be squared. All right, and then after that, so make sure you didn't miss anything, but that would be your answer. So the distance between those 2 points would be 6.32, and a distance is a length, so we're just going to put units. So that would be the distance, 6.32 units. Okay, so that is one way to find the distance, is use the distance formula. The other way would be to use Pythagorean theorem. So I'm going to show you how you can do that. Okay, so you would grab your graph paper. So I'm going to see if I can squeeze this on there at the same time. So with my graph paper, you're going to graph your coordinates. So I've got one at, or the first one's at 1, negative 2. So make sure you graph them correctly. And then the other one's at 3, 4. So 1, 2, 3, 1, 2, 3, 4. All right. And then you connect them. All right. There is a reason you connect them. So what you're really doing when you find the distance between them is what is the length of this line. Okay. So again, you can use the distance formula, or after you graph the points, if you're using Pythagorean theorem, you would connect them and draw your right triangle. So what I mean by the right triangle is you're either going to go from one point to the other by making a right triangle. So you can go up and then to the right, or you can make the triangle on the other side and it'd be the same thing. So you would go to the right and then up. Either way you want to do it, okay? So I'm going to go this way, and you'll notice if you look at the other triangle here in a minute, it'll work the same way, all right? So there's my right triangle, so I'm going to put my little right angle with where that goes. And then, to be able to use Pythagorean theorem, remember you're looking for the length of this side right here, you're going to have to find the lengths of these other sides. So these are your legs, and so you just count. So this one has a length of 2. That one has a length, and count the spaces and not the lines. So that'd be 1, 2, 3, 4, 5, 6. So that's at 6. So what we're going to do is use Pythagorean theorem and plug these in and find the hypotenuse in that triangle. Okay, so using my Pythagorean theorem, we've got a squared plus b squared equals c squared. These are my legs, so it would be, and it doesn't matter which one you put first because you're adding them. So it would be 2 squared plus 6 squared equals, and then you're finding this side. So that would be like your side C, okay? So then you just solve, okay? So I'm going to move this graph so that we can solve. So you just simplify. So 2 squared is 4 plus 6 squared is 36, and then that equals C squared. And then combine them. So 4 plus 36 is 40. And now, to get rid of the square, the opposite of squaring something is square rooting it. So I'm going to square root both sides. And when I do that, my C would equal 6.32 units, which is the same length as what we got over there. Okay, so no matter which way you do it, you should be getting the same distance. All right. So you can choose whichever one you want. If your coordinates were decimals, then using Pythagorean theorem would be a little bit harder. So knowing the distance formula is useful, but Pythagorean theorem is easier for when it's problems like this. Okay, so what if we had to find the distance of these? Well, Again, you can use the distance formula or you can graph it and go from there. So I'm going to show you both ways here, and then you'll realize that something's kind of strange with this one, all right? So if we use the distance formula, I'm going to write my coordinates down, label them, and then plug it in. Okay, so from here, it would be the distance equals a big square root. So remember, you start by taking your x values and subtracting them. Okay, so this would be like my x1, my y1. That would be my x2 and my y2. So I take my x2 minus my x1, so it would be 6 minus 0 squared, plus, then I have to take my y values and do the same thing. So it would be negative 8 minus a negative 8 squared. And make sure that's all under the square root. And then you type it in. So if I type this one in as a whole, the distance actually ends up being just 6, okay? So now, if you were using the other method, you would graph your coordinates. I'm going to grab my coordinates here, or my graph paper. I'm going to graph them. So I got 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's where 0, negative 8 is. And then I've got 6, negative 8. So 1, 2, 3. 5, 6, and then go down to negative 8. Let me make sure that I didn't. 1, 2, 3, 4, 5, 6. All right. Now notice this one is a little bit different because if I connect them, we're finding the length of that. Well, that one, you can actually count how far they are apart. So if you graph them and you can count how far they are apart, like it's exactly lined up to where you can count the spaces, and it's not like at a diagonal like that one was, then just count. So make sure you count the spaces and not the line. So 1, 2, 3, 4, 5, 6. So the distance between them I know is 6 without having to do the Pythagorean theorem. So it might be useful to graph them at first to see if it's one of those. All right. So this last one here, again, you can use the distance formula and notice we got the same thing. Regardless of which way we did it. So the last one, you'll notice there's something kind of special about that as well. And so you could graph that one, and that one would actually be one, if you graphed it, you could count, okay? And so you could graph it and count, or I'll just show you the distance formula just so you have another example of the distance formula. So this would be your x1 and your y1. That would be your x2 and your y2. I'm going to plug it in. So it's a big square root. Start with your x values. So it'd be negative 2 minus a negative 2. Okay, and then don't forget to square it. And then it's plus. You take your y values and subtract them. So it'd be 18 minus your 3. Okay, and then just like I did before, you would just type that in. And so with this one, the distance would end up being 15. Okay, and if you graphed it, both of these have an x value of negative 2. And so really, you just have to figure out how far 3 is from 18. And notice, if I figure out, like if I take 18 minus 3, I end up getting 15. And so that the distance would be 15.